Okay, YouTube, this is my third video on function transformations, and in this video we're going to focus on, as a matter of fact, combinations of transformations. We talked about translations, reflections, as well as verticals and vertical and horizontal stretches and shrinks. But in this instance, what we're going to do is talk about combinations of those things. So I do want to state this. There is, as a matter of fact, an order that you want to do your transformations in. Okay, you want to do them one at a time and in the stated order. So when I say in the stated order, let's just go ahead and take a look at this example. We'll talk about how I have two steps here, but it says let the graph of h be a horizontal stretch by a factor of 8. So we have some horizontal stretch here by a factor of 8, followed by a translation 10 units down of the graph of some f of x here equals x, which is our parent function, our linear parent function here. Then we want to write a rule for h. Okay, so what I want to point out here in this video is essentially this. When you write a transformation of functions, and it's a combination of transformations, we always write reflection transformations as well as stretches and shrinks first. That always occurs first. So notice I say first we'll write a function h, and we'll allow this function h to represent that horizontal stretch of f. And what we were told was we have some h that needs to be a stretch of a factor of 8 of f of x. So we say h of x is going to be a horizontal stretch of f of x. Now what do we remember about horizontal stretches? Well, what you're going to do is you're going to take all the initial x values times a factor here. Okay, so we're going to take all of our x values in here times a factor. And the thing that's also really important to remember is when it comes to horizontal stretch, okay, it is stretched by a factor of 1 over a. 1 over a, where a is the factor that we want. So if a is a factor of 8, then what we're going to put in here is actually 1 over a. So it's going to be the reciprocal of that stretch factor that we want here. So now having this, basically, we're going to say now what I want to do is write a function g that represents the translation of the stretch function h. So in other words, we have this function h here, and what we want to do is write some new function g of x, and g of x is really just going to be h of x, and we want it to be shifted, what, 10 units down. So remember what we know about vertical translations here. Vertical translations, either up or down, we're either adding on or subtracting off some constant here. We usually use the letter k to denote this. So we're going to say g of x is really just h of x, where what we want is to have it shift down 10. Okay. So now doing all of our substitutions here, basically what do we know about h of x? Well, h of x is f of 1/8 x. So we have g of x is this function here, and we say, well, h of x is equal to f of 1/8 x, and that's been shifted down 10. And now we'll just find, using a substitution here, what the heck f of 1/8 x is. So our initial function was f of x equals x. Well, then all we need to do is say, well, then I just need to plug in for x here, this 1/8 x. In for the x, minus 10, and we get g of x here. So just to explore this, I do want to take a look at it. All we need to do is kind of maybe hop over to our Desmos graphing calculator, and I say, well, I've already got f of x equals x in here. So what we were doing was we were saying, well, I've now got an h of x, and h of x was equal to f of 1 divided by 8, and that was times x. So you notice that h of x was this horizontal stretch by a factor of 8. Everything on this initial relation here has been stretched outward in terms of x values by a factor of 8. And then we say, well, now I've got some function g of x, and g of x was actually equal to h of x, but we had taken 10 off of it. So it's kind of hard to see here, but if I were to kind of shift out or zoom out a little bit here, you can see that we've actually shifted it down 10. So really, using what we found here was a new function here. We had this 1/8 x minus 10. Let's actually go back into here. And I'm actually going to type in, well, then g of x, we said, is equal to 1 divided by 8 times x minus 10. It's kind of hard to see, but you'll notice that this green graph here, I'll click it off there, is actually overlapping the blue graph that we had there. So this green graph, written this way, is the same thing as our initial function f of x, where we stretched it by a factor of 8 for h. And then took that value, which is h here, and we subtracted 10 off of it. So that's how you would work a combination of transformations. It's just really important that you perform your stretching, shrinking, and reflections first, and then do your translations last.